So, yep, I'm Bojan Endrovski. I'm co-founder and I'm also the developer at GameOn. I'm going to talk about cooking your own game engine, but actually it will go a bit broader than that. So it's not a very technical talk, so there won't be like lines and lines of code or anything like that, and I won't go much in detail. So even if you're not doing your own engine, if you just happen to miss some things in whatever tool you're using, this would be like I hope that's a small guide on how to go over those bumps. The synopsis had lots of cooking innuendos in it, so I have none of that in the actual talk. But I did do all my drawings throughout the talk, so that will provide enough like comic relief. And yeah, we can get started. So, although we got a bit of an introduction from JP, thank you very much for that. But I'll still go over some of the things that we've done for those people that don't know who we are. I don't have a switch here, so I'll do this and go to my iPad. Yep, it's a live demo. Yay. So, that's Reno. That's the first game. It was IGF nominated, and it also last year won the Dutch Game Awards in two categories. It won Best Handheld and Best Casual. So, the premises are pretty simple. And it's mostly an intimate game that you play with someone else on the iPad. This one was kind of a long production, that's mostly because we took our time. Two students trying to do a game together, so it was kind of on and off for quite some time. And this featured like a very early version of the tech that we later on used. Then we went on to build this game. For a publisher, for a book publisher in fact. And this is a bit more like game-like, with game-like features and like camera, you can fly around. This is just a small demo of the stuff that you can do. Full planet. I think this game was when it was completely built out of clay, photographed, painted, and then put into the game. Kind of a slow process, but it works. It has a specific feeling to it. And this is a later game. I don't know how to do it. Bamboo. It's also a physical game on the iPad, kind of similar to what we usually do. And this uses like the latest iteration of our tech. I don't really have versions or anything, but if anything should showcase, this game should more or less be the game that showcases it. And we see here running on the iPad, I don't know how much you can see because I think the output is like 15 frames per second, but the game is running 60 frames per second, which you don't see all that often. There was a loading time. Basically, it loaded everything within that frame, and if we go back to the menu, that's the time it takes to load the menu. This is our GUI system. You can't really see where my finger is, but it's on top of this carousel. We'll go to the options. And we'll decide to go for language, and we can change languages on the fly, including my native Spanish. And we can go for more exotic languages like Korean. Yep. So that's Bamboo. And now we can switch back to my presentation. Tell you how we did these things. Okay, what problem is this? Yep, this demo will work, it did work. So, Curiosity is kind of the name of the tech that we're using. It just stuck out, mainly because I had a blog called Furious Pixels that I was reading, and then the namespace I decided to call Curiosity, and from that it kind of just stuck out. And it predates about 1 year Game On. So this was there before Game On was found, and I worked on it. Initially it was done in C#. We made a game called the Jelly Reef for the Microsoft Surface with it. But then we kind of decided to move on into a different direction, and I rewrote the stuff in C++ so that I can get it to work on iOS and later Android as well. In total is small, 23,000 lines of code. I think that in Awesomenauts, I guess you guys know that game. In Awesomenauts, the character code itself is about 100,000 lines of code from what Jos has told me. So our whole engine is 23,000 with few thousand written in different languages. We have a bit of glue to the iOS written in Objective-C. We have a bit of glue to Android written in Java, and we have quite a bit of Bash script. Now, I think most of you would not gone in that direction. Probably we should not have gone either. Do you guys know what Bash script is? It's the Linux. It's basically the Unix scripting language, and it's all unflexible and difficult to work with. But for some reason, it was a natural choice. And then we have some JavaScript, mostly to script in Photoshop, because that's what Photoshop supports on multiple platforms. And we don't do, we don't do everything from scratch. There are a few things for which we use libraries, and we use TinyXML for streaming, libpng for loading PNGs, FreeType for fonts, and we have full UTF-8 support, which is the Korean font that you saw. And that's also something that we didn't write from scratch. But most of like the rest is something that we did in-house. And I also try to keep as much as I can, because I am the only developer on the team. This is the only full-time. We had an intern, 1 or 2 interns during in the last 2 years. But I still try to keep things as neatly as possible, and I'm using Doxygen to document. So this is like the documentation for the engine. And I think that I can even cut the presentation and go straight here. And okay, it doesn't show this. Okay. So yeah, I write lots of documentation. Maybe we can find something small. So, one way to help yourself, if you are going to write copious amounts of code, is to document everything that you do. It will help you. You might see it as a slowdown, but it will help you down the road. Okay. So those are the things that we've done so far. And we're still working on a few things, and I'll make a small demo of that as well. Yeah, I'll switch. So a usual working day, like in Game Over, would be me working on a prototype or working on a game, and then Adrian, the designer, will have some requests, sometimes silly, sometimes simple. Let's see. One of the things that we really wanted that we set out to do was, let's do good 2D games. And for 2 years we didn't do anything with 3D. And then we had a discussion somewhere 2 months ago. Adrian asked me, so do you think we can do 3D? And I was like, well, give me a week, I think we can squeeze some 3D in it. And it took a month to get some things running, but this is a very simple 3D sphere. These are all small particles. But this is not what I wanted to show you. What I wanted to show you is that we also decided to build the system for really, really fast iterations. So all the resources I can store on my laptop, and connecting connecting through the Wi-Fi, now the device should load. I'm not sure, but if it will work, it should load the resources from the laptop, store it locally, and reload it locally. And that would give you really, really fast iterations without you needing to every time rebuild the game not from scratch, but even if you do have to stop it and rebuild it, it can take a while. Or you're in the middle of the level and you're not in the mood to stop the games just so that you can change some texture or something like that, or sports thing. So I then would come with like some idea like, okay, we have these circles that we can see everywhere. What if we make them stars? And I was like, no, stars will not look nice. And well, I would get an answer. And this is not how design works. You need to try it out, you know it. And sure enough, let's try it out. Okay, let's see if this works. Yay, stars. So, as you can see, stars don't look good. And that's the debug glow. This is where my touch is. So, that was a bit of an intro about what we do, and now let's talk how we do it. As I said, this is my level of my skills of drawing. This is what we are used to saying. Like if you use Unity, this is the way you would approach a game engine. You have your textures, your models, your sound, your game scripts, and you just put them in this black box, and on the other side, a game appears, and that's it. You don't care what happens in between, and this is quite difficult to do because for this, the guys at Unity are doing much of the heavy lifting for you. And that means that everything, they need to build all the tools that everything that you do happens within that box. The box is what you communicate with. What we have is quite different, and I think that many game companies also have something that's different. There is a framework. It's a bit more complicated, and it works in a way that you have your textures, models, and sounds, and they don't directly go into some box. But what we have is game first. The game loads those things. The game uses those things, but it uses the library, it uses a framework to do that. So I named this talk "Cooking your own game engine" because game engine sounds cool, but in fact we don't have a game engine. We have a framework. So the game comes first, both physically and also philosophically. We are not building technology so that other people can do things with it. We are building technology so that we can make the perfect games that we want to make. And that's a bit of a different approach. So our textures go through tools, our models go through some scripts and tools, then our sounds go through tools, and then our settings actually right now don't go, but they could. And that thing then gets loaded by the framework and goes into the game. So it's a bit of a, we basically put the tools closer to where you make the content. So you don't import them into the engine and then let the engine take care of it, but you use them where the content is made. We have a super simple gameplay system. There is like a base entity, and then there is, from that we have an entity 2D, I'm missing the 2D there. We have a GUI element, which is also an entity, and then we have a 3D entity. So those are like the very base classes. And then we have entity container, which has flat structure, so no scene graphs, no trees, nothing like that. It adds and removes entities, and it does that in a way that it's consistent across the frame. You don't want to delete enemy 5 and then 3 lines after that you might be needing enemy 5. So it provides a bit of consistency there, and it just updates all the entities. And out of that we have world 3D, and then we have the GUI, which is also an entity container. So we can see that this class is templated. I don't know how much you guys do you know what templates are? Yeah? Okay, awesome. We use them quite a bit because they're very helpful. And we can see here that we just get completely different functionality out of a super simple templated class. And then those subclasses can do things like collision handling, events, queries, and so on. So we can pass some events, we can do queries about proximity, we can play some animations in the case of GUI events. and such. Now, the entities themselves, when we set out to do something new in the game, we use something that I think it should not be overused, and I think we are overusing it, which is multiple inheritance. This thing doesn't exist in C# and it doesn't exist in Java, and it's considered to be bad design in those places, but here we use it a lot. So our spaceship will be an entity that also is a vehicle, and that also is collidable, and that also is renderable, and it can handle input from a controller. It can also spawn some particles to have like a nice flame in the back, and then it has a light source in front of it, and it has few weapons on it, and it's also a space unit, which means, I don't know, it has health and things like that. So then the spaceship has all of those things. Those are not components that you create or anything, but your spaceship has all of those things. This is quite easy to write usually. It produces relatively small code, and it's quite quick because all the data is there. So it's extremely cache friendly. And as you go into optimization, you realize that cache is one of the biggest influence on how quickly something performs. The less memory you touch, the better, and the closer it is also better. The problems that might arise are you might have inheritance diamonds there. If you use multiple inheritance in C++, you would know what it is. It's not too bad, but it's something to be aware of. It's not really scripting friendly, and we do lots of casting from one type to another. So we get a I don't know, a space unit, and then we also know that it's collidable, so we need to do some casting around. And for that, we need to be careful, because C++ might be linearizing on us without us noticing. We also have a relatively smart-ish resource management. So we have our textures and, I don't know, sounds and scripts which have been loaded by the resource manager. But we also have hooks to anyone that uses those, because we might have multiple places in the game where we're using a single texture, and that would not make sense to make another copy for each one of those textures. So what we do is we just increase the count, how many users we have there for a certain resource. And you can see that's my attempt at drawing the hook, because I thought the resource would be, it is actually a hook towards, a resource reference is a hook towards a resource. Those references might also store some additional data if we decide to do that. And they are done in a smartish way. It means that when they run out of scope, they release themselves. Now, this in C# is something that, again, if you're using Unity, something that you really don't care about, but one of the biggest problems in most of the time spent when developing C++ is chasing after memory leaks. And this thing prevents you from having memory leaks, because it automatically releases the resource once it gets out of scope. So you don't have to delete the object, release the object yourself. And we can see here the counts for each one of the resources. So a resource manager needs to load the resource, release when it's no longer being used. Those I already explained. But then it also needs to inform all the users of a certain resource that something has changed. So if we have settings file and we decide to reload on the fly like we did here, then, I don't know, it's a radius or some explosion, then we go and tell the explosion that the next time it needs to run, the radius needs to be a bit bigger or a bit smaller. And one neat thing that super simple actually to implement and extremely helpful that we added was template replacement. We have these wildcards, as you can see here, with size and LNG. We can place those anywhere in the path to a resource, and just before loading, those get replaced with certain values. And this is the way that we can handle different languages, different sizes, different resolutions. Basically anything that we want, we can replace. It's a very simple system to set up, and it's extremely flexible. Now, much of our time goes into making user interface. User interface is something that is lacking in most, if not all, engines that are out there. There are a few overly complicated libraries that try to solve everything. I don't know, like PuTTY or or something like that. Usually they are very broad, extremely difficult to use. And most of them have very little support for touch. So we built this kind of from scratch. And about 25% of the engine is exactly that. But when we start out to write code, in our case, in our games, about 78 to 80% of the actual game code is creating windows and destroying windows or buttons and things like that. And one of the most difficult things to do right on touch is a nice carousel. Something that kind of feels right. It needs to have enough inertia. It needs to snap at the right time. When you touch it, it needs to stop doing whatever it was doing before. And it needs to give you a nice hint when you have reached the end and so on. And this is something that we just have not found out there. So we decided to build it and refine it over the last 2 years. Now, we also have a very simple animation. So I'm going to, this is basically as simple, all of these examples are as simple as, at least I think, they're as simple as you can get while still having the functionality to build a game with. And every time I have a chance to make things simpler, I also do that. And the code base does not only grow, sometimes it also shrinks. So we have animation, which is basically super simple interpolation from one value to another value, but then you choose how you're going to interpolate from between those values. And we also have two animation containers that completely rely on shared pointers inside to do all the memory management. Because with an animation, it's very easy to say, okay, now play. But what happens, whose duty is when it's done playing to release itself? Maybe it's in use in some other place. So here again, we're using similar structure like with resources. We're using shared pointers so that we don't run into memory problems. And we have two simple containers. One is a sequence, the other one is composition. Now this can be freely combined together. As we can see here, this really bad drawing there at the bottom, that would be one timeline. So we can see we have a composition, because those things, composition is something that runs at the same time, and sequence would be animations that run one after the other. So we can see like we have two lines, so we have a composition. Each one has two sequences there, and then we can see to the right, we can see a tree of how this thing is structured. So we can have at one time, we probably will be running, I think, at most 3 animations in this particular case. Does that make sense? Can you see that? I think it's not all that clear. So this thing at the bottom is like one timeline as you would have in Flash, and a single color represents a single animation. And it goes from left to right. So to the right we have a tree out of it. I think the drawing is definitely not clear enough, mostly because I didn't want to put text on it, but maybe I think I should. But we have this free-form structure that any sequence can have a composition, and any composition can have a sequence inside, and that sequence, and so on. Basically, this can be infinitely nested. So that's only how they are structured. But all the actual work, all the animation is done by a simple parameter animation, which is this heavily, well, not heavily, but this templated class that does all the animation. But most of the time it's too verbose to use it, so we just subclass that into whatever we need. We used to have sprite fonts for the GUI, and that means that we would build one big sprite texture freehand, and then just have vertices, basically have triangles made to represent our letters when we need to draw something on the screen. Now this is nice because you can use your computer to do nice aliasing. It's quite quick to do. It's quick to change the text because you only rebuild your buffers. But because it's pre-made, one sprite contains only one size. Otherwise, it just looks ugly. You need to do it freehand, and it's not really doable for Asian or Arabic fonts because you cannot have a table that's big, basically. You cannot have something that will contain all Chinese characters. So what we did instead for later on was to do like proper font rendering. We're using free type, which is like proper pain in the ass to compile on most platforms. But it is what I think what macOS, iOS, Android, and all of those platforms use to do their own internal rendering. So it's high quality. It's high quality rendering. It's very flexible. It can render any size, but it's a C library, so it can be a bit involved to make it work properly. And it's kind of slow because we also first we need to see how big of a texture we need. So we need to go through the string, and it's also slow because we need to redo the whole texture every time we change the text for a layer. But that was the reason why we could do Korean and Chinese and Japanese and so on. Now I explained a bit how our GUI system works. And because it's kind of verbose, it's flexible, but it's verbose to write all of those buttons and things like that can be slow. What we do is we use Photoshop as a GUI editor. So what you see there on the left is basically that is our asset. So this will not go into another program and then get reassembled or whatever. Within Photoshop, you press a button, and as long as your file has a structure that all the elements that you want to use in the game are put in a single group, then you will get lots of images exported out of that and an XML description that will give you the type, the relative position, the size, and the name of whatever object you have. And that thing then just goes into the engine, and then you have the screen that you saw at the beginning of the game. Now you do need to set up all the buttons yourself, that they have an action, that when you press something, we don't do that in Photoshop. So that's the only thing basically that you do from your code, or should be. We also use it as a level editor. So our games are 2D, so why not use it as a level editor as well? So it's a slight modification of the same script. It's not anything dramatically different. So to the left there, we see that one file contains all our levels. We know exactly how those will look in gameplay. And then we have like 2 samples from that file. And then at the very bottom right, we see that's like in-game. Screenshot. The problem is that out there is a sea of resolutions. The smallest resolution that we support is like, what is that, 100 of a megapixel? Something like that. And the highest resolution that we support is 4 megapixels. And the aspect ratios also, they vary like widely between a device and a device. But we always want our games to look like they were done for that device. So what we do is we have quality settings, and we also have kind of smart scaling for the GUI. And now visually what you see here is the iPhone 3GS at the bottom, and iPad Retina resolution side by side. So this is the difference in the resolution between those 2 devices. Now, first, of course, we need to find a way to do framing for that, because the resolution aspect ratios vary so much. So what we do is we have this safe frame where everything that you really want to show needs to be there. And then instead of cropping, what we do is we just show more. So we either show more to the side, or we show more towards the top and bottom. And it's a very, very simple formula, the one that we see to the right. So we have the aspect ratio of the screen and the ratio of the world that we want to show. And based on that, with that small formula, we can decide whether we make things wider or taller. And how does that look in Photoshop? Well, like this. What we see here is the safe frame, the nicely colored things. Then what we see kind of grayed out left and right and top and bottom, that is where we would expand if the screen resolution is different from the safe frame, if the aspect ratio is different from the safe frame. And then what you see there at the corners is basically stuff that we never show, the 4 corners. We also did the localization by ourselves. And that included the font rendering that I showed and the UTF support. We also did lazy string binding, so we never really store the actual string until we need it. We use a string ID up till the last possible second, and that's when we replace it with a text that it represents. And we can reload on the fly, so we can change the language without you needing to restart the game or anything like that. We made Google Docs. We use Google Docs for this because we were collaborating with Utrecht. It's a company that does translation services. Now, it's a bit of a long road to get from there to the game because of the way that Google Docs works. So we needed to export as an Excel sheet, but then we needed to open it not with Excel, but with OpenOffice because of the support because Excel lacks the proper Unicode support, at least on Mac. Then from OpenOffice, we would export to comma-separated values, and then from comma-separated values, we would go to XML, which is used in the game. I'm still amazed that this thing works. And we decided to go multi-platform for our last game. And I must say, there's no silver bullet like this magic trick that will make you go multi-platform. It's just lots of work. I mean, if you're doing it yourself. So first we kept our code physically separated. We had Java files and multi-module files. And that helps because iOS and Android kind of force you to use different language. So C++ is like what is platform independent, and then all the things that are not C++ is the things that would be used on a certain platform. Usually you have to wrap some functionality, like we did for the touch and the sound and so on, the things that are different file handling. But some things you need to rebuild. It's an easier way. So iOS has a pretty decent math library, but it's only on iOS and it's Objective-C, so we decided to write our own. To go multi-platform, you need to be really strict with your coding standards because you're going to use plenty of compilers which might work differently, so you need to really stick to the standard C++. And on mobile, actually, the biggest problem is not the code itself at all, it's the asset pipeline. How you're going to get your assets from one side to the other, how you're going to get from whatever you do in Photoshop or what you recorded as sound to the device. And here is where we use plenty of scripts, and we also use plenty of tools. The tools that were not available, we made them and we put them on GitHub. So you can download some tools there for different compressions and so on. So the situation on Android. We support all the 4 texture formats. These are hardware compression formats, which we need badly to keep our game running 60 frames per second. That's why you don't see that on mobile, because most people would stick to the uncompressed and then just use that. But we always use hardware compression, or almost always, unless the quality is really paramount. So we support PVR, ATC, DDS, and PNG is actually our uncompressed because that thing in memory then gets uncompressed. And this thing gets filtered by the Google Play Store. So we set some flags. So users that have a device that only supports PVR will not get served all the textures because that would make a huge file that they just don't need. And we might go into a situation where they cannot download the game while they're not on Wi-Fi, and we don't want that. Like that's not a good thing. Someone is there in the train, wants to download the game, they better be able to get it straight away. So the filtering is done by Google Play. Now then, the game gets started once it's downloaded. Next, the system decides which library it's going to load, and we compile 3 different libraries for ARM, ARM7, and Intel. Next, our game is running, hopefully with the right architecture being selected. Now we need to select our quality for the textures, and we have low, medium, and high. And that is handled by the game depending on what is the size of the screen. And this is what we use all of those wildcards for. So if I just say this is .image, that image will get replaced to either PVR, ATC, DDS, or if it's .sound, it will get replaced by a wave or cup or whatever the platform is using. And we can see that on Android we have a total of 36 versions that you can get out of gaming. And they all run pretty, I would go as far as saying they run perfectly. Like, they load in less than a second, and they usually take as little as like 30 megabytes. Actually, at most 30 megabytes of memory, and they can take as low as 3 megabytes of memory. I don't think there are lots of new games that manage to do that, or actually that even bother to do that. Now, one thing is loading all of those assets. The other thing is packing all of those assets. So we have this monster of a script that intern wrote. It's completely unmaintainable because it's like 2,000 lines of bash script that kind of no one knows exactly how it works. But what it does is it takes all the assets that we have and it goes one by one and compresses them in all the right resolutions, in all the right formats, and then writes some files about where those assets can be loaded from, and so on. And now with those assets, then we call some more scripts to do the packaging for us. So basically we just call a couple of scripts one after the other. They do take time to execute, but with few script calls, we have all those 36 versions that I previously showed on the slide. So that's how we get our games looking and feeling the way they do. And yeah, I wanted to have a shorter talk than usual, but I'm open for any questions. And I think I've left plenty of time for questions, right?
Yes. Yeah. Applaus, applaus.
Okay, guys, so I hope it makes sense to you. I'm not a programmer, so anybody who has a staggering, are you just stretching or is that a question? Okay, yeah, hang on, the microphone is coming your way. Do you have any clipping for the carousel?
Sorry?
Any clipping, so can you hide parts of your carousel?
Yeah, we use the stencil buffer to do clipping. It's quite a straightforward implementation. You just enable the stencil buffer, draw a rectangle as big as your carousel, and then just use that as a clip mask.
Do you have an abstract renderer? Could you put DirectX in there if you would want?
Yeah, all the rendering goes through single class, which is like a sprite renderer, and that thing does all the batching and everything. And if we just make one more version of that uses DirectX, that could do DirectX. As I said, it's not the code that is the problem, but it's getting a Visual Studio project running with all the different kind of assets, and then that thing communicating with the rest of the system. Otherwise, rendering should not be more than, I don't know, I would say a couple of weeks overall.
Any more questions? Mark, any question maybe from another programmer's point of view? No? Any questions about Game Oven, the games? Fingal, go ahead.
I'm wondering, I just looked the game up on the Play Store and it's free. So what is the reason for doing that? Why not have people pay for it just like...
Are we talking about Benfu?
Yes, Benfu.
So, switch to Benfu then. Well, it's fine if you just play in Korean, I know the minutes. Oh. Oops. Maybe Korean doesn't work. So, this is the free version. You get to play with two people, but for 3 and 4 players, we ask you to pay $1. So it's not completely free, but it's almost there, and that has contributed to us having like 500,000 of downloads and not that many sales. So giving too much is not something that I would recommend. And the gameplay is pretty similar in terms of how many players there are, but I think it's more fun with 4. But users don't think it's worth $1.
I guess the trick is with free to play is first.
We haven't balanced it as free to play. Then it's more of a gift than it is a game.
It works. I mean, it works for some games. It works really well. It's just the way because we're all kind of spoiled, so we just don't want to pay anymore. But then once you really like it, you can buy more content. That's the whole idea behind the free-to-play games.
And this is a nice way to lead into the next presentation. We was on hint from Jan Willem. We actually put screen shake in a completely to the physical.
There you go. Hey. Great. But before that, any more questions? Anybody here? No? If you have any more in-depth questions, you can ask Bojan afterwards. He will be hanging around. Are you going to stick around today?
I'm here.
Yeah, great. Bojan, just a quick thing. What's anything on the next project you're working on?
Yep. We're working on basically tomorrow we're releasing a very experimental game. It's called Friends Rap. And to celebrate me and my colleague Adrian, it's a game of endurance. How long two people can kind of stay together, and we'll try to break our record of being together. So we'll hold for 24 hours and we'll live stream on Twitch.
So live stream tomorrow starting at 5, right?
Starting at 5.
And where can they find you? Through your website? Or how
and if you go to GameOnStudios.com, the very first thing that pops out is the live stream.
And they're supposed to stay awake for 24 hours all night Wednesday. So.
And I think that we'll be at our office at the Dutch Game Garden, and if anyone feels like stopping by, bring us some soup or whatever.
At around 5 o'clock. And if you're bored and it's Wednesday night, 2 o'clock in the morning, or going Thursday, then you can chat with them and keep them awake and try them out. Okay, thanks a lot.
Don't bring us milk and cookies, that way.
That's right.